Hey everybody, I'm your four-eyed professor, Chris Lievens, and I'm super excited to talk to you today. Our roll call is for new and experienced ODs, optometry students, and even those just interested in this profession. We'll cover a number of topics together, and I'll help you see them through a professor's eyes. Please take your seats. School's in session. Welcome back to the podcast, everybody. Thanks for attending. Over the past few months and really the past few years, I have had a few casts and recordings about what I still think is one of the items in medical care that goes widely unknown, and that is the ability to do research in a typical private or commercial practice, or even an institutional setting. And in those recordings, I've posed some questions. Hey, if you have any questions about this, please feel free to email me. By the way, it's foureyeedprofessor@gmail.com, the number 4-eyed professor. And I did actually recently receive a couple questions, especially on the topic of statistics. So I am bringing to the stage my favorite statistician, Dr. Nancy Briggs. Hi, Nancy.
Hello. Thank you for having me.
You have an American accent, but you are in Sydney. Tell us your journey and how you got to be where you are now.
I actually didn't start out as a person who did statistics. I have my degree in psychology, and in the middle of that degree, I realized I really enjoyed statistics and got my PhD in quantitative psychology. And then when I was done, I joined a group at the University of Adelaide in Australia that does statistical consulting. And I worked there for 9 years. And now I am at the University of New South Wales, and I'm the director of their statistical consulting unit. And I've been here since 2016.
Fantastic.
Mm-hmm.
So the questions that came to me, and I really hope that folks continue to send questions on this topic, because I do think it's not as well understood, or maybe it's a discomfort zone, is a phrase I'll use, and maybe an intimidation factor for someone that wants to do something independently, but maybe doesn't know exactly where to get started on the analysis front. So please continue to send questions my way, and we'll continue to answer them as they come in. Well, here's number one. We're doing a research study. We're designing a protocol. How do we determine the right number of subjects that we're going to need? I mean, sometimes it's really convenient to say, well, we'll enroll 10 because 10 is a nice round number. Or we'll pick 40 because that's a nice round number. But that's not exactly what we should be doing. So what should we do?
First of all, it is good that you are thinking about this at the very beginning of the study as you're planning it, because it is really integral to that very start of the research process. And doing a formal sample size calculation really depends on a number of things. It depends on how your outcome is measured. It depends on your study design, what your research question is, and how you're going to analyze it, so your analysis model, how precise you might want that estimate to be, the level of power that you want to set at, and your type 1 error level, your alpha level. So those last two things are sort of some statistical concepts, but everything else is sort of general research questions and research design issues. So it's really integral in the very technical statistical aspects, but also in the more accessible, less technical aspects of research design. And it relies on, it's based in all of those areas and those questions that I mentioned. You can be guided by your intuition in how to do these types of calculations. So you can be guided by what you know as a researcher and what's been published before. And those are two really important sources of information as you are building your sample size or power calculation.
So let's say we have an established project that's been published, well received. with a very particular design, and we're doing something either analogous, very similar, or parallel to what's already been done. How do we use that information to do a power calculation?
Yeah, obviously, if they're looking at the same or a very similar outcome, you can use the mean and standard deviation, either of, if you're comparing groups of the two groups, or of the mean difference between them, if that was their research focus. You can use that information in your sample size calculation. Things to be aware of are if you have a different population, so perhaps they looked at a healthy a population, whereas yours might be people who have some sort of eye condition.
Right.
So that going to affect their responses on that particular outcome. So you need to be aware of things like that. Another thing that's really important to look at is if they are reporting I don't know if they're doing a group difference, maybe they did an RCT, and their primary outcome that you're drawing the information from was, a 12-month follow-up. Right. But your study is looking at maybe 3-month follow-up. So you need to keep that in mind, that perhaps the change over time looks different for the different time periods. So you might want to adjust your sort of the values they might use. You might use the quality, and then you might estimate a slightly less extreme, mean difference at 3 months than at 12 months. Something like that. The other thing is that it's good to rely on previous research, but also be more conservative when you're using those values in your own calculations. And by conservative, I mean make it a little bit harder for your study to reach the level of power. It's just being a little safe. So that at the end of your study, you might have reached the level of power that you think you did.
So let's use the hypothetical situation you just described a moment ago. Let's say previously there's been some work done that was a 12-month longitudinal study, and we're studying something for 3 months. And lo and behold, at 3 months, we recognize that our mean standard deviation is way different from the earlier study. Yeah. And we just don't know, is our populace just different? Are our findings different? Or did time really play a factor here? Do we then just enroll more and see what happens, or add duration, or how do we handle that?
Yeah, that's a really good question. If you're turning out that, at the end of your study that at 3 months, it really does look quite a bit different from that 12-month previous study, I wouldn't simply just enroll more people, or because that was not part of the research design. Right. And particularly if you're doing an RCT, you may have pre-registered your research design and plan. So you would have to follow that. But I would
randomized clinical trial.
Yeah. Yes. Yeah. Particularly if you're doing a randomized clinical trial, you may have even been required to register the protocol. Of course. Yes. So you always have to follow that. But in that protocol, you may have things like define some interim analyses, so that 3-month thing could be an interim analysis, and you may be following up people after that, and that's totally fine. But you did say that you were going to test it at 3 months and report on that, and that's okay, because you thought about this study before in this possibility, and you do that anyway. But if your study was just like, nope, at 3 months, that's going to be our follow-up, and you found that you have quite different things, it's actually good information to publish anyway, because the more information out there in this particular outcome is more information for people later on to build off of. Particularly, I'm thinking of meta-analyses and stuff from a statistical sense, but of course in a clinical sense, it's useful that way too. the things that you can think about are, yes, you mentioned how are your populations different? Are they? The difference in time frames as well might give you some real good information on how that treatment is working. And so I think that whatever result you do get is important and worthy of reporting, and following the protocol that you had determined at the beginning. I am very much ecumenical on results. Results are results, and you have to report what you get, and not unless you have in your interim analysis, you will change your sample size, or you'll stop the study, or you will keep going. You don't change that based on what your results are. Yeah. You might use it to guide another study. Yeah. Mm-hmm.
So you mentioned various type errors, and that's closely aligned with the power calculation. Is that
absolutely right? Yeah. When people learn about hypothesis testing, doing research in a hypothesis testing context, we mostly focus on what's called type 1 error. That's also called our alpha error, and that is the probability of rejecting a hypothesis when there's actually nothing going on in the population. And we usually set that at about 5%, but there's no special reason why it has to be 0.05. It's just sort of conventional. But there's another type of error. It's called a type 2 error, and that is the probability of not finding a true effect in your study. And this is not focused on as much because it seems it's sort of deemed as a less serious mistake than the type 1 error mistake. But it's also something that we can actually control a bit more in our research and the decisions that we make. So we can minimize our type 2 error by having good research design, using good measures, increasing our sample size, and all of those will help us minimize that type 2 error. And most studies, when we do power calculations before we actually do it, we want to keep that type 2 error rate at 0.2 or 0.1, and particularly for larger randomized controlled trials. Now they expect the power to be at least 90%.
So you're leading us right into the other question that I decided that based on the email response that I got, or email query that I got, and that is, you mentioned that you typically said by convention these days, type 1 error to be 5%. So so we're looking for statistical significance where p-values are 0.05 or less. So how do we? So I believe this is otherwise said that if 95% likely that the results you have are not based on random chance. Did I say that right?
It's close.
How should I?
It is the probability, assuming that the null hypothesis is true, that you reject that null hypothesis. So So it's very close, but it's not quite the same.
So how do we handle it when we get a p-value of 0.051, where it's not being that marker, but we understand mathematics and numbers, and it's really close?
It is really close, and I absolutely agree with you. Let me back up a little bit and talk about our inferential statistics. When we do these types of research studies, we are generally interested in not just describing our sample, but making an inference from what we see in our sample to a larger population. We're inferring something about the larger population from our sample. And that p less than 0.05 is relating to one type of inferential statistics, and that is hypothesis testing, where you get a yes-no answer. Is your p-value less than 0.05 or is it not? And that's important information, but it's also a little dissatisfying in that it's not, you don't get a very very good idea about what is actually happening. So there's another part of inferential statistics called estimation. And that is very much related to the hypothesis testing. Not only do we get a p-value, but we also get an estimate of the effect that we're interested in and a confidence interval around it. Now, if somebody did a research study and got a p-value of 0.051, I would interpret that as providing evidence against the null hypothesis, and then also present the estimate out of the mean difference, if that's what you're interested in, with its confidence interval, and say and not simply say, well, I guess we didn't find a significant effect. I always interpret p-values as providing evidence against a null hypothesis or providing no evidence, against the null hypothesis. And a p-value of 0.051, I'm still going to say we have some evidence, and then say this is our effect.
We're still able to tell a story. We just have to.
Yeah, absolutely. And in particular, if you have, more than one sort of research question of interest, and it's consistent with those other research questions, because often our outcomes are correlated. If it's consistent with those other ones, I think you have some pretty good evidence and a really interesting story. So I would not be upset at all to find a p-value of 0.051. I would always interpret that with the estimate itself and the confidence interval, and say, hey, I think that we have an interesting thing here.
Sure.
So I'm really happy when I see stuff like that. For the researcher.
I forgot to ask you an item before when we were talking about power calculations.
Yes.
And we have a mean and standard deviation from a paper that's very similar to our protocol design. There's a number of websites out that exists on the internet.
Yes.
Where I can simply go type this in and get a calculation.
Yes.
Are those reliable? Are those okay to use?
Oh, yeah. That's a really good question. And I have used some of them. There are a few that are based in epidemiology that I trusted, and if I need a quick calculation, particularly for a proportion, I use those. I would look for websites that have been there for a long time, and usually they're based in a university. So those are the ones that I would use that for free. There's also free software that you can download. G-Power is if you search for G * power, that one is free, and for straightforward sample size calculations, it's great. And you just have to note that if you do move into some sort of the more complex statistics, the documentation and what you need to know and understand might be kind of hard. So you might have to spend a little bit of time with the manual to make sure that you're doing things right, or ask for help. There are lots of statistical software packages that now include sample size calculations just as part of it. Obviously, R, if any of your listeners are aware of R, is completely free statistical software with tons of different packages that are all user created and supported. So that's always a really good choice. It does require coding.
Got it.
SPSS has just recently included power and sample size calculations as one of the modules in the basic package. So if you have one of the later versions, might be starting with version 27 or 28, where you can access powers and sample size calculations. You can do it in there. And then, of course, we've got, if you've got SAS or STATA, those have had sample size calculation capabilities for a very long time. So those are some really good resources. If you have grant money and you are able to buy software, and you need to do lots of sample size calculations, there's a package called Power and Sample Size Pass, which is Amazing, fantastic. We use it all the time. So that's my very favorite thing to do sample size calculations in. It's got great breadth of different outcomes and study designs and statistical approaches to these types of questions. So I would highly recommend it. It is very pricey, which is why I said if you do have a grant and are able to buy, then it'd be good. But it's not accessible for everyone.
Yeah, like everything in life, you pay for what you get. That's just the way the world works these days. Well, you are my statistics guru, my statistics go-to person. I hope that we get some more questions come in, and if so, I'll reach out to you again. So long as we can coordinate our time zones.
Absolutely, happy to. And if anybody listening really, has a quick question, you can either email me directly, Nancy Briggs at unsw.edu.au, or Chris, and he can forward it on to me, and I can
Perfect. I'll do it.
I'm happy to answer quick questions and get you guys going.
I love it. Thanks, Nancy. Enjoy to see you again.
Nice to see you.
Hey, family. If you enjoyed this full podcast, don't miss out on more engaging content. Check out the next episode right here. And for the latest updates, hit that subscribe button and ring the notification bell. Your support means the world to us. Catch us in the next episode. Peace.